Our topic of discussion is IUPAC nomenclature of organic compounds. You know, for an organic compound, there are three parts for a name. The first one, for example, ethanol. This is actually what is called the word root. And this is actually what is called the suffix. Sometimes there will be a chlorine atom. We can call that to be 1-chloro ethanol, and in that case we can call that to be a prefix. So an organic compound name contains a prefix, word root, and a suffix. Normally word root and suffix are mandatory, prefix is optional. Actually the word root. Okay, word root actually that talks about the number of carbon atoms in the chain. The word root deals with the number of carbon atoms in the chain. And the suffix, there are two types actually. There are two suffixes. Actually, eth is the word root. Eth is the word root. And there are two suffixes, an and ol is there. An is actually what is called a primary suffix. And ol is actually called a secondary suffix. Primary suffix that deals with the nature of the chain. If it is an alkyne, that means it contains only single bond, the name will be AN. If it contains double bond, the name will be EN. If it contains triple bond, the name will be YN. And we have got secondary suffix. Secondary suffix deals with the functional nature of the compound. Deals with the functional nature of the compound. Okay, for example, if we have got OH, here in ethanol, we have got OH. OH, we name end in oil. If it's an aldehyde, the name we end in AN. If it's a ketone, carbonyl group, if it is there, the name is in ONE. If there's COOH, the name will end in oic acid, etc. Okay, this is the primary and secondary suffix. So the functional nature of the compound is given by the suffix. The nature is given by primary suffix and the actual functional group is represented by a secondary suffix. Now let us see where we use the prefix. Generally, we use prefix to represent less important functional group. So we use prefix to show less important functional group. For example, okay, NH2, we call amino. Chlorine, we call that to be chloro. Nitro. These types are generally represented by less important functional group. So prefix is generally used to show less important functional group. It's actually what do we call that to be IUPAC name. IUPAC nomenclature. This is the anatomy of the IUPAC name. You know that C1, if there is only one carbon atom, we call the word root will be meth. There are two carbon atoms, word root will be eth. There are three carbon atoms, word root will be prop. And there are four carbon atoms, it will be but. There are five carbon atoms, it will be pent. 6 carbon atoms, it will be hex. 7 angle, it will be hept. If it is 8, it will be oct. If it is 9, it will be none. And if it is 10, it will be duck. So if it is C11, it is called unduck. If it is C12, it will be doduck. With sorry, 16. For example, let's see, going to be some complex case, called hexadeck, trideck, like that. And if it is C18, it is called octadeck. And if it is C20, it is called ICOS. Okay, this is how we can represent the word root. Okay, this is how the word root is there. As I told you, we are having different type of functional groups. Some functional groups are actually called important functional groups. Some of them are less important functional group. Now let me tell you the order of preference of the functional group. We're going to talk about the order of the actually preference of the functional group that we're going to see now. The most important functional group, the important order of priority, actually is first priority comes to the normally SO3H. It is sulfonic acid. The first priority is actually goes to sulfonic acid. After that, the priority generally goes to carboxylic acid. Then comes acid anhydrides. Then comes esters. Then comes acyl halides. Then generally comes amides. Then comes cyanides. Or we can call that to be nitrides. Then comes aldehydes. Then comes ketones. Then comes alcohols. Then comes thiols. Thiols are also called mercaptans. Okay. Then actually, these are some of the very important class and actually type of name. Okay, then we are having actually amines. Then we are having ethers. Then comes thioethers, alkenes, alkynes, haloalkanes. Haloalkane, halogen containing compounds. Then comes nitro compounds. Then comes alkanes. These are the order of preference of the functional groups. The general order of the preference of the functional group is like this. The most important priority goes to sulfonic acid. Then comes actually carboxylic acid. Then comes acid anhydride. Then comes esters, acyl halides, amides, nitrides, aldehydes, ketones, alcohols, thiols, and amines. Thiols, amines. Then comes alkenes and alkynes. Among them, alkenes and alkynes, alkene is having more priority over alkynes. Then comes haloalkanes. Then comes nitro compounds and alkenes. This is actually how we can name the functional groups. This is how the priority, or sorry, this order of priority of the functional group. Some books says that carboxylic acid is higher than sulfonic acid. No problem. We can choose anything. That doesn't matter at all. For example, we are going to see the IUPAC nomenclature of this compound. This is actually a alkane. Alkane because the carbon is having only single bond. It's an alkanic system. This carbon atom is having OH and COH. The first thing we have to do is to know the longest chain. So you number the longest chain. It is 1, 2, 3, 4. Okay, so this is actually 1, 2, 3, 4. The compound contains 4 carbon atoms. So it is actually the word to dispute. And the compound, the thing is that the carbon contains only single bond. Carbon single bond is only there. Therefore, it will be butane. The highest priority is COH, so it should get the minimum number. And the thing is that the compound should be known as the highest priority one. The compound should be known as an acid. But we have got actually OH here. OH is actually another functional group. That's about the functional group. We can call butane 2-ol. Then we can call that to be oic acid. Some book says that butane 2-ol 1 oic acid. Doesn't matter at all. Here's how we should name. Sometimes we write 2-hydroxy butanoic acid. It's also right, but this is the more correct way of naming the things. So if you want to know more, you may refer to your old textbooks. I'm just giving you some examples for refreshing. Another example we are going to see is CH3, C double bond O, CH2, C triple bond N. This is cyanide. Let us see how can you use the name for the compound. So the compound number is 1, 2, 3, 4. Again, it's but. The compound should end as a nitrile. Because cyanide IUPAC name is nitrile. But there is a ketonic group in the third position. So we have to write it as oxo. But 3-oxonitrile. This is the naming for oxo, IUPAC naming for oxo when we use that as a prefix. Sorry, primary, less important function group. Now, let us take an example in which we have got this compound CH3, C triple bond C, CH2, CH double bond CH2. See this compound. Okay, let us see how can you name the compound. It is 1, 2, 3, 4, 5, 6. One way of numbering. Other way is 1, 2, 3, 4, 5, 6. The word would be sex. Remember from the previous slide, you can see that always who should get the preference. Alkenes are more important than alkynes. So a double bond should get minimum number than that of an alkyne. So in this case, if you write like this, the first carbon atom is actually a double bond. Therefore, at number of double bond will be 1. If you write like this, the double bond will be having number 5. So this pattern is more preferred. So hex is actually hex. Once the carbon, there is a double bond. And in the fourth carbon, you can see in the fourth carbon, there is actually a triple bond for I. That means that the compound should known as an alkyne. The compound should known as an alkyne, but double bond should be given the minimum number as per the IUPAC rule. It is actually what is the IUPAC nomenclature. These topics I just giving you some refreshment of the things that you have studied in the previous classes. Now, what I'm going to do is that I'm going to introduce you to a very important compound. We're going to study that compound because as per our study, we have to study this type of compounds. Those compounds are called, first type of compound are called spiro compounds. Spiro compounds. Spiro compounds are compounds actually where two or more rings are linked in one common atom. Two or more rings are linked by one common atom. For example, this is one ring. There's another ring. The two rings, and these two rings are connected by the common atom. Common atom. There's actually a common atom. Okay, it's actually what is called a spiro compound. Two different rings are connected to a common atom. It's actually called a spiro compound. When we name the spiro compound, we have to name it as a spiro compound. Okay, the name is actually spiro. The name is actually the spiro. So you can see if you had a number like this, first carbon, second carbon, third carbon, fourth carbon. This is the fifth carbon. Junction carbon. You should not first put number 1 over here. You have to put in the other way 1, 2, 3, 4, 5. Then 6, 7, 8, 9. So compound is having total 9 carbon atoms. So the compound is actually a non-name. Non-name. Now you can see that in this ring is having 1, 2, 3, 4 atoms. This ring is also having 1, 2, 3, 4 carbon atoms other than junction. So we can put a square bracket over here and we can put 4.4. So compound name is spiro square bracket 4.4 nothing. It is how we can name this compound. So what is again a spiro compound? Spiro compound is having, or a spiro ring system is having two or more rings linked by a common atom. They linked by actually a common atom. There are different methods to name the compound, but this is one of the best method or simplest method to name the spiro compound. I will show you more examples. When you learn more examples, you can see that it's very, very simple. See, this is example. Let us see another example. This ring is having 1, 2, 3, 4, 5. But see this another ring, it is having only 4. So let's number it. So 1, it is how we had number. The number to the smallest one. Number to smallest one. Here 1, 2, 3, 4. Here also 1, 2, 3, 4. So we put either way, no problem. Here it is 1, then 2, 3, 4. It is the 5, 6, 7, 8. So the compound is actually an octane. We know the compound is a spiro compound. An octane. And there's actually a square bracket to show the number. You can see here, there will be 1, 2, 3 atoms. Here we can see that there are 1, 2, 3, 4 atoms. So we can put here 1, 2, 3. So 3 dot. Here we have got 4 atoms. So it's called 3.4 octane. The compound name is spiro square bracket 3.4 octane. This is the name of the spiro compound. Now I will give you many examples as possible. This is another example. Let us see this another example. This example again is spiro compound because the spiro junction. This carbon atom is having junction because it connects the two rings. See, one ring. This ring contains 1, 2, 3, 3 atoms only. The ring contains only 3 atoms, but this ring contains 1, 2, 3, 4, 5 atoms. So this is ring junction. Here we have to start with 1, 2, 3. Because why we hold like this? Because this is having the minimum number of atoms participating in the ring. 1, 2, 3. It is 4. It is 5, 6, 7, 8, 9. Again, it's actually a non-name. You can see it's a spiral compound. So then we got a square bracket. Here we got 1, 2, 3 atoms other than the junction in this ring. So 3. Here we got 1, 2, 3, 4, 5 atoms other than the junction. So it is less number. So it is 3.5 non-name. It is a compound name, Spiro 3.5 non-name. It is the name of the compound. Okay, now what you can do is that let us see another example. This compound. Let us see what is happening in this compound. It is 1, 2, 3, 4. Because it's a 4 member, 5 member, it's 6 member. 4, 5, 6, 7, 8, 9, 10. So it is actually a decade. It's actually a spiral compound. So there will be, here there will be 1, 2, 3, 4 atoms in the ring. In the ring. So it's 4. Here also we have 1, 2, 3, 4, 5. So Spiro 4.5 decade is the name of the compound. Now let us see another case in which we have got this compound. Okay, so this is having a double bond. It's an unsaturated spiral compound. So this is the lowest number. Let's number like right like this. Is 1, it is 2, 3, 4. Junction is 5, 6, 7, 8, 9, 10. So the compound is having 10. It's actually a spiral compound. The square bracket is deck. But the problem is that it is not an alkane, it's an alkene. So it will be decene. Now we have to put the double bond position. The first atom, second atom, double bond is between the first and second atom. Number is dec 1 in. And you can see that here 1, 2, 3, 4 atoms are here in other than the ring junction. Here 1, 2, 3, 4, 5 are there. Spiro 4.5 dec 1 in is the IUPAC name of the compound. It is how we can name these spiral compounds. It is the IUPAC nomenclature of spiral compounds. Now I will give you a work to do here itself. Can you name this compound? It's very simple. The name is Spiro 4.4 Nana 2,7 diene. Here duck is only there, but here there is di. A numerical prefix is used, therefore we have to put a letter A here. The component is Spiro 4.4 Nonna 2,7 diene is the name of the compound. I will give you more exercises to work on this type of molecules. Now we are going to see bicyclo compounds. We're going to see the nomenclature of bicyclo compounds. Bicyclo compounds means molecules that having two joined rings. So the compound is having two joined rings. Sometimes it's called bicyclic compounds also. So also called bicyclic compound or bicyclo compounds. They are the same. Okay, it's very simple to write the bicyclic compounds. For example, see this compound is actually a ring. There's another ring. There's another ring connecting between the first ring. This one ring and this is another ring. These type of compounds are called bicyclo compounds. It's having two rings, so it's called bicyclo compound. Okay, this is an alkane because the compound doesn't have got any carbon atoms. So it's an alkane. Now let us see how we can name the molecule. Unlike otherwise, here what we can do is that we can name the compound with this number, this with from here, this position. 1, 2, 3, 4, 5, 6, 7, 8. It is how we write the compound. Okay, so it's an octane. So its compounds having 8 carbon atoms. It is actually what we call an octane. So compounds bicyclo. Compound should name is bicyclo. But you can see that this is the 2 carbon atoms. In between, there's a bridge. The bridge is having only 2 in between. So it's 2. This is the bridge. This is the bridge. Here also, there's another way. This is also having only 2 carbon atoms. Here also, it's having only 2 carbon atoms. So name is bicyclo 2.2.2 octane. The compound name is bicyclo 2.2.2 octane. Bicyclo square bracket 2.2.2 octane. This is the name of the compound. Okay, let us see another case. This is a compound. First, let us count the number of carbon atoms. 1, 2, 3, 4, 5, 6. And the 1, 7. So it's actually heptane. So this is one path. This is one way. This is having only 1 carbon atoms. 1 carbon atom. There will be 2 carbon atoms. And this is having 2 carbon atoms. Okay. So ഇവിടെ നമ്മൾ എങ്ങനെ എഴുതും നോക്കാം. ഇവിടെ 2 ഉണ്ട്, ഇവിടെ 2 ഉണ്ട്, ഇവിടെ 1 ഉള്ളൂ. 2 ഉണ്ട്, 2 ഉണ്ട്, 1 ഉണ്ട്. ഇത് കുറയുന്ന ഓർഡറിലാണ് എഴുതാൻ വേണ്ടി. ഇറ്റ്സ് കോൾഡ് ബൈസൈക്ലോ. എന്താണ് 2.2.1 ഹെപ്റ്റേൻ എന്ന് വിളിക്കുന്നു കോമ്പൗണ്ട്. Compound is called bicyclo 2.2.1 heptane. See this compound. This again, there are 2 cycles. There is cycle, there are cycle. There are 2 cycles. Okay, so compound name is not the 1, 2, 3, 4, 5, 6 carbon atoms on the. ഇവിടെ ഉള്ളത് ഇത് നോക്കിയാൽ അറിയാം ഇത് ഇവിടെ കൂടി 7 ആവും. So the name is heptane. Okay. ഇതെങ്ങനെയായിരിക്കും സൈക്കിൾ ചെയ്യുന്നത് എങ്ങനെയായിരിക്കും? ഇവിടെ നോക്കിയാൽ അറിയാം ഇതിനും ഇടയ്ക്കാകെ ഒരു കാർബൺ ആറ്റമേ ഉള്ളൂ, 1 ഉള്ളൂ. ഇതിനും ഇടയ്ക്കാകെ ഒന്നല്ലേ ഉള്ളൂ, ഇതിനും ഇടയ്ക്കാകെ ഒന്നല്ലേ ഉള്ളൂ. അപ്പൊ ഇത് 1 ആണ്. ഇവിടെ നോക്കിയാൽ അറിയാം ഇതിനും ഈ ജംഗ്ഷനും ഇടയ്ക്ക് എത്ര എണ്ണം ഉണ്ട്? 1. ഇതിനും ഇടയ്ക്ക് 1, 2, 3 എണ്ണം ഉണ്ട്. അപ്പൊ 3 അല്ലേ? അപ്പൊ കോമ്പൗണ്ട് പേര് എന്തായിരിക്കും? കോമ്പൗണ്ട് നെയിം ഈസ് ബൈസൈക്ലോ 3.1.1 heptane എന്ന് പറയും. The compound name is bicyclo 3.101 heptane. This is how we can name bicyclo compound. ഇങ്ങനെയാണ് നമ്മൾ bicyclo compound നെ നെയിം ചെയ്യുന്നത്. Let's see more examples. ഇതെങ്ങനെയായിരിക്കും നോക്കാം, ഈ മോളിക്യൂൾ എങ്ങനെയാണെന്ന് നോക്കാം. So again here 1, 2, 3, 4, 5, 6 here and 1, 7 here. The 7 carbon atoms. This again we can call that to be heptane. So it's bicyclo. So it is having 1 in between. ഇതിനും ഇടയ്ക്ക് ആകെ ഒന്നല്ലേ ഉള്ളൂ, ഇത് 1 ആണ്. 1 ഉണ്ട്. ഇവിടെ 2 എണ്ണം ഉണ്ടല്ലേ, ഇത് 2 ഉണ്ട്. ഇതിനിടയ്ക്ക് 2 എണ്ണം ഉണ്ട്, 2 ഉണ്ട്. അപ്പം 2, 2, 1 ഉള്ളത്. അപ്പൊ നമ്മൾ എഴുതും ബൈസൈക്ലോ അസെൻഡിങ് ഓർഡർ ഡിസെൻഡിങ് ഓർഡർ എഴുതണം 2.2.1 heptane. ബൈസൈക്ലോ 2.2.1 heptane. ഇത് രണ്ടും ഒന്ന് തന്നെയാണ്. ഈ വരച്ചേക്കുന്നത് രണ്ടും ഒന്ന് തന്നെയാണ്. ബൈസൈക്ലോ 2.2.1 heptane. അങ്ങനെയാണെങ്കിൽ വേറൊരു ബൈസൈക്ലോ കോമ്പൗണ്ട് ടിപ്പിക്കലി നമ്മൾ എപ്പോഴും പഠിക്കുന്ന ഒരു ബൈസൈക്ലോ കോമ്പൗണ്ട് പഠിക്കാം. ഡെക്കൈൻ ആണ്, ഡെക്കൈൻ കോമ്പൗണ്ട് ആണ്. ഓക്കെ, ഇത് എത്ര എണ്ണം നമുക്ക് നോക്കാം. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. ഡെക്കൈൻ ആണ്, ബൈസൈക്ലോ ആണ്. നോക്കില്ല ഇടയ്ക്ക് ഇതിനും ഇടയ്ക്ക് ഒന്നിനും ആറിനും ഇടയ്ക്ക് എത്ര ഉണ്ട്? 1, 2, 3, 4 ഉണ്ട്. അപ്പൊ 4 ഉണ്ട്. ഇതിനും ഇടയ്ക്ക് 1, 2, 3, 4 ഉണ്ട്. 4 ഉണ്ട്. അതേസമയം 1ഉം 6നും ഇടയ്ക്ക് ഒരു റിംഗ് ഉണ്ട് അല്ലേ, സൈക്കിൾ ഉണ്ട്. പക്ഷെ ഇവിടെ ഇടയ്ക്ക് കാർബൺ ആറ്റംസ് ഉണ്ടോ? ഇല്ല. അപ്പൊ നമ്മൾ എന്ത് 0 വരും, 0 വരും. ഈ 1നും 6നും ഇടയ്ക്ക് ഒരെണ്ണം ഉണ്ടാവേണ്ടതാണ്, ഇവിടെ ഇല്ലാത്തതുകൊണ്ട് 0 എന്ന് എഴുതുകയാണ്. അപ്പൊ ഒരു കോമ്പൗണ്ട് പേര് എന്തായിരിക്കും? ബൈസൈക്ലോ 4.4.0 ഡെക്കൈൻ എന്നായിരിക്കും ഈ കോമ്പൗണ്ട്. ഈ കോമ്പൗണ്ട് നോക്കാം. ഇത് 1, 2, 3, 4, 5, 6, 7, 8, 9 ആണ്. ഇത് 9 ആണ്. ഇതിന്റെ പേര് ബൈസൈക്ലോ എന്ന് പറയണം. ബൈസൈക്ലോ എന്ന് ഇവിടെ 1, 2, 3 1, 2, 3 ഉണ്ട്. ഇവിടെ 1, 2, 3, 4 ഉണ്ട്. ഇടയ്ക്ക് 1നും 5നും ഇടയ്ക്ക് ഇല്ല, അപ്പൊ 0 ആണ്. അപ്പൊ ബൈസൈക്ലോ 4.3.0 എന്നാണ് കോമ്പൗണ്ടിന്റെ പേര്. It is the IUPAC nomenclature of bicyclo particles. Thank you very much.